All right, guys, today we are continuing with our distributive property, and we are going to, you need a book? Grab one on that shelf. We are going to continue with our distributive property and our math properties, and we're going to move into greatest common factors and least common multiples. But the first thing we're going to do is review the different types of numbers. So look at the bottom of your page where it says review. It says circle the prime numbers, cross out the composite numbers, and use a box to identify any number that is neither prime nor composite. I am not going to go over the definitions with you. This is something you should have learned in 5th grade, so I'm going to see what you remember. And I'm going to give you about 4 minutes. This is individual work, not table work. And we will come back and discuss in 4 minutes. Go for it. All right, who can tell me what a prime number is? Madeline? Okay, I like the way you said that. Does anybody have anything to add? Okay. I like the way both of them said that. She talked about multiplying and she talked about dividing. It is a number that can only be divided by 1 in itself, and you can only multiply 1 in itself to get there. Does that make sense? It cannot be divided by 2, 3, 4, or any other number. Just 1 in itself. So who can tell me some of our prime numbers in this list? So it only has how many factors? It has 2 factors, 1 and 3 or more. Good job. Yes, it only has 2 factors, 1 in itself. So who can tell me some of our prime numbers? 20 is not a prime number. Okay, 30 is a prime number. Jack? 5. Y'all just tell me. 1. 1 is not a prime number. We'll talk about that one in a few minutes. Say that again. 13. Just tell me. 11. What else? 2. 17. 19. 7. We've got 13. Are there any other ones? 1. Okay, so let's talk about that. I've heard 1 more than once. Why is 1 not a prime number? Who remembers what Jen said a few minutes ago? Prime numbers have how many factors? 2. How many factors does 1 have? It only has 1, because it is 1. It's the loneliest number. So is it a prime number? Is it a composite number? No. No, it's neither. So this is the one that needs a box. Good job. All right, and our composite numbers. Again, he gave us a hint. They have what? So we already have 2 factors for our prime numbers. They have 3 or more. It means you can multiply other numbers to get there, or divide them by other numbers other than 1 in themselves. So our composite numbers are all of the numbers that are left. Make sense? Good. Look at the next page, please. Okay.
You pushed a whole lot of buttons that made no sense.
Because I'm only 5 feet tall.
This is true. Yeah, so we're on page 14 in your modules. Page 14.
Yeah, sorry, we're skipping enough pages, guys.
Yeah, and this one, we're going to talk about factor trees. You can express any whole number as a product of primes if only primes, nothing else. So, for us to do this, we're actually going to talk about this a lot this year, but right in this area right below where it says habits of mind, I want you guys to write this. 4 key numbers. In math, especially when we're doing stuff like factors, prime factorization, any type of GCF, LCM, any type of simplifying. There are 4 numbers that are really critical for you to understand, being able to break things down. Those 4 numbers are 2, 3, 5, and 7. So we're going to talk about these numbers a lot this year to the point where you guys should have them all memorized. So if you want to memorize them now, feel free. It'll save you some time. We'll say it so often, by the end of June, we'll have these 4 numbers memorized. Why? Because any number up to 121 is either divisible by 2, 3, 5, or 7, or it's a prime number. Why is 121 special? Because 121 is the first time we get to the next prime number, which is 11. 11 times 11 is 121. But 121 is not divisible by 2, 3, 5, or 7. So the next one would be 169. So what we're saying is basically up to 200, there are only 2 numbers that are not divisible by 2, 3, 5, or 7 that are composite. So if you can check these 4 numbers, say is this number divisible by one of these 4, it'll tell you if the number is composite or not. And you literally just go through the list. Start at 2, go to 3, go to 5, go to 7. So what am I talking about? Let's take a look. This is what we call a prime factor tree. So there's 2 things that are happening here. One is a factor tree. That is the tool that we use to find the prime factors of a number. The second is what we call prime factorization. Prime factorization is writing a number as a component of its prime factors. So with a prime number, prime factorization is going to be 1 and that number. If it's a composite number, you're going to break it down into the prime numbers. Here's a good example. If I take the number 30, I go to my 4 key numbers, 2, 3, 5, and 7. I say, can I divide 30 by 2? Yes. Okay? So if I can, then I do what we call a tree. I make 2 branches. 2 is one of my prime numbers, so I'm going to circle that. Then I write the other factor. In this case, it would be 15. So 2 is, this branch is now dead. I can't go further than that prime number. So now I check 15. I write 15 by 2. No, by 3. Yes, so I do so. When I do another branch, I say, okay, I can multiply it by 3, and then the other factor is 5. Well, that's one of my 4 key numbers. So I circle them all, and now it's dead. So that is my factor tree, but I have not yet written the prime factorization. The prime factorization is I now take these numbers and I write them as a multiplication sentence. Always start at the lowest. So the prime factorization of this is 2 times 3 times 5. If you ever wonder, did you get it right? It's actually really easy to check. What's 2 times 3? 6 times 5? 30. The prime factorization should always get you back to the number. If it doesn't, you did something wrong. Make sense? Okay. So this one says to create a couple more on your own, but we'll go ahead and do one with you. Just to help everybody understand it. Because I always like to go in order. It makes it really easy. Plus, if I go in order, my prime factors are all going to be lined up in order to make prime factorization easier to write. However, I don't have to technically use 2 as a start. So we think of another set of factors I could use to get 30. Or 3 times 10. So 3 times 10 is 3 a prime number? Yes, I circle it. What about 10? Can I break it down? Yes. I make it 2 times 5. Those are prime numbers, so I can now circle them. So if I rewrite this prime factorization. What's the smallest number? 2 times, what's the next smallest? 3 times 5. Is it any different? No. As long as you don't make a math error, it won't be any different. And you can get there from any set of factors of the number. But again, just for ease of use, highly recommend start at 2, go to 3, go to 5, go to 7.
Alright, everything you write in the book is okay.
If you say no to all 4 of them, it means prime number, and the prime factorization is be 1 times the number. Okay? Go ahead and turn the page. Okay, now we're going to give you guys a chance to practice this on your own. So you got 2 parts, create a factor tree and write the prime factorization for each number. So you have 2 tasks to do, you've got 3 numbers to do it with. So we'll give you about 6 minutes to try to do this, and then we'll take a break, and then we'll continue on from that point. So go ahead and start working. Try to do it on your own. Once you've got it done, you can compare answers and someone else at your table. Okay, so I have quite a few struggles on this. A lot of you really kind of didn't pay attention to what I said, so let me demonstrate to try to make this easier for you. I will say that up front, realizing there are multiple ways to get to the right answer. What I'm going to show you is how to get there very quickly every single time. Okay? Literally, all I do is I start at my number, 24, and I say, can I divide that by 2? Yes. If I say yes, then I do it. My first branch is 2 times, and then I just got to figure out what that number is. So 2 times 12. Every time I get to a prime number, I circle it. If it's not circled, I need to double check that number. Okay? I divide 12 by 2. Yes. So then I do another branch, and then I just got to figure out the other factor. 2 times 1 is 12. 6. 2 is prime, so I'm going to circle it. I check the 6. Can I divide it by 2? Yeah, so then I do it. 2 times 3, that's one of my key numbers, so I know I'm done. Once I have them all circled and all the branches are dead, now I just rewrite it as a multiplication sentence from smallest to biggest. So I have 2 times 2 times 2 times 3. That is my prime factorization. Does that make sense? Okay? So my next number, 81. I can check. I divide 81 by 2. Right? I divide by 2. 1's an odd number, so I have to have an even number to divide by 2. Can I divide by 3? What's 8 plus 1? What's 8 plus 1? 9. Can I divide 9 by 3? Yes, I know I can divide the whole number by 3. So, just so everybody understands. So, another key reason we can do 4 key numbers is they should be easy for you as far as divisibility factor. 2, if it's an even number, I can divide by 2. 3, I add the digits up. If I can divide that digit addition by 3, then I can divide that whole number by 3. I just got to figure out what it is. Okay? So in this case, 8 plus 1 is 9. I know I can divide it by 3. I just have to figure out what the other number is. So 3, I can circle because I know it's that. So how many times will 3 go into 8? 2. So there's 2 left over. 6 is 2. But the one after, how many times will 3 go into 21? 7. Okay? So guys, those of you that weren't tracking, what I just did is I just did this mentally. I said, okay, 3 goes into 8 twice. And there was 2 left over, so I put the 1 after it. 3 goes into 21 7 times. Get to 0. Make sense? Then I just check again. 27. I know I did by 2. By 3. Yes. So then I do it. 3 times 1 is 27. 9. Can I divide 9 by 3? Yes. So I do it. 3 times 3. So now I rewrite my prime factorization. 3 times 3 times 3 times 3. Now, a lot of you did 81, 9, 9. That's awesome. Remember, we can do that, right? Here's the key, though. If I just do my 2, 3, 5, 7 every time, I'm going to get to the right answer, guys. And normally, single digit division by 2, 3, 5 and 7, it's pretty easy to do. But if you did the 9 times 9, that's great. What's 9 a prime number? Can I divide it by 2? By 3? Yeah. 3 times 3. What about 9? Can I divide it by 2? By 3? Yeah, so I do it. 3 times 3. Did I get the same answer? Yes. So did it really matter? No, but getting into habits, building habits is going to make it easier for you. If you just go through that checklist, 2, 3, 5, 7 every time, guys, you'll get to the right answer. Let's make it happen. So either way is acceptable. I just really prefer that you guys get into that habit of just going through your checklist of 2, 3, 5, 7. Okay? So this will be a really good example. I'm going to erase this for room space. Can I divide 96 by 2? Yes. So I can do that. 2 times, how many times will 2 go into 9? 4 with 1 left over, so 16. 2 goes into 16. 8 times. Can I divide 48 by 2? Yes. 2 times 24. Can I divide 24 by 2? Yes. 2 times 12. Can I divide 12 by 2? Yes. 2 times 6. Can I divide 6 by 2? Yes. 2 times 3. Now I've got them all written out. See how it lines it all up nice and neat. Now to write my prime factorization is just 1, 2, 3, 4, 5, and the 3 at the end. So rather than having to struggle and try to figure out what's going to go into it, if you'll just go through your checklist of 2, 3, 5, 7, guys, obviously it'll be quicker most of the time. Of the other factors I could have used for 96, yeah, there's a whole lot of them. And any of them would have gotten you the right answer. But this does a really good job of lining it all up for you. And quite frankly, the math should be easy. I'm dividing by 2. That's not hard. I'm dividing by 3. Any questions on what we just did on this? Okay, everybody should make sure you have all this written down, because we are going to need this in just a second. Right now, you need to pull out your highlighters and or colored pencils. We're going to mark it on text a little bit. Okay, we've got a couple of terms we need to talk about, because this is actually a really confusing topic for a lot of students. And it's when we get into exponents. Okay? Believe it or not, guys, exponents are actually really easy. Here's part of the problem, though. A lot of you don't have vocabulary down correctly. So we need to talk about the vocabulary behind an exponent. The first one is the term power. The term power means it has 2 elements. We have a base and an exponent. So normally you guys think of this entire thing as an exponent. It's not. It's actually a power. The base of the power is the factor multiplied by itself repeatedly. So in this case, our base is the 2. Okay? The other part of the power is the exponent itself. The exponent is the number of times you use the base as a factor. So the exponent is the little number. The bad part is, unfortunately, most students refer to the power as an exponent. It's not. The exponent is just that one number. So just to verify that everybody can do this math correctly, who can tell me what 2 to the 4th power equals? 8, right? Are we good with that? Okay, thank you. I just said everybody agrees with that, right?
Raise your hand if you
Oh, we want to pin you down. How many agree that 8 and 2 to the 4th equals 8? Raise your hand. Okay, hands down. How many say 2 to the 4th is not equal to 8? Uh-oh. Ruby, what do you think it equals?
2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 17.
Yes, you guys just made the single most common error made in 6th grade math. I literally asked you what is 2 to the 4th equal, and I said, couple things on this guy? I will write wrong answers on the board to help make a point. Good. Sorry. That's what I'm going to back on. Good. We'll be walk through what 2 to the 4th power means. Okay. 2 times 2 is 4. 4 times 2 is 16. Well, if you are ever struggling with your exponent, highly recommend you write it out in extended format. Okay? If you write it out, you're much less likely to get it wrong. 2 to the 4th power is not just 2 times 4. That's repeated addition. That's 4 plus 4. The exponent is repeated multiplication. 2 times 2 times 2 times 2. Does that make sense for everybody? Okay, critical factor. Because so many students mess this up, I guarantee you will be on the enemy test that you're going to see that comes from the district. Okay? So please get that down now and save us all a lot of heartache. Okay, when we are reading a power, we're actually talking about it. There's a lot of different ways we can say it. A couple of the most common is we'll say 2 to the 4th power. So 2 to the 4th power, or 2 raised to the 4th power, or 2 to the power of 4. Okay? Those are all the verbiage for how we say it. So on these next couple, they want you to identify the base and exponent in each power. So I'll give you a hint. They want to say the base is what, the exponent is what, and then they want you to write each power in words. So you can take either of these phrases and just substitute the numbers from the problem. The second part is we're now going to write the prime factorization, question 3, using powers. So you've already got the answers for these. They're all right here. All I'm going to do is now I'm going to write these using powers. I've got a couple students that have already done that, but they were just a little ahead. You're actually supposed to do that now. You don't have to do the whole prime factorization tree. We've already done that. You just need to now write that using exponential notation. Okay? So this should only take you about 4 minutes. We'll give you about 3 minutes to go. Eight, yeah. Yeah, about 13. On this one, there were 2 parts. So for part A, my base was 7, my exponent was 5. Then I need to write it how I would say it. So this would be 7 to the power of 5. Or 7 to the 5th power, anything like that. There's a lot of ways you can do the saying part. Here, part B, my base is 4, my exponent is 8. Good. And I did a power of, so this time I'm going to say 4 to the 8. That's a fun word to spell. Power. Make sense? Okay. For number 5, all we're doing is literally going back to the examples that we just did on this page. So for 24, how many 2's did I need to multiply? 3. Was that the only number? No, there was also a 3. Now, if my exponent is 1, don't write it. So by seeing just the whole number, the implication is it has an exponent of 1. So technically it would be wrong if you put a 1 there, but mathematically a lot of times we don't write things that are there that we don't need. That would be one of them. Make sense? Okay. What about the 81? What did we have? 1. Awesome. You even said it well. Good job. 3 to the power of 4. What about for part C? Good. Awesome. Good math vocabulary again. Well done, guys. Good job. Good. Any questions on anything that we covered so far today? It's starting to make sense to you. Anybody have any last questions before we wrap up for today? Okay, so don't forget this. We're going to pick up on in this next class period. Your homework for tonight. We did the pre-log protocol during math class on last Tuesday. So most should have finished the pre-log protocol. You're now going to do the next 4 sections of the first workspace. So as you do that, you'll see it basically mirrors exactly what we've gone over. Stuff like the distributed property, introducing an exponent. So do those first 4 Matthews sections. For the record, this won't be actually graded until the end of the quarter, but it's highly recommended you catch up on it. What do you guys have at the end of today? Seminar. That's what a perfect time to do stuff like that is. Seminar. If you don't have other work.
Guys, if you look to the left of your map, it says a number out of 122 workplaces complete. After tonight, you can have 5 out of 22. I mean, 100. There's a 3-lot protocol in the first 4 work. Okay? Make sure you're keeping up with your dashboard.
Yeah, so when we take 4 workspaces, that doesn't mean the entire module, guys. I think the first module has 29 workspaces in it. Okay. So you don't have to do all of them. You can work ahead if you want to. Again, it's self-paced, but the requirement is your pre-launch and then the next 4 out of the napkin. Any questions on how to get there, where to do it? A lot of times, most of the bars on you have to look for it's more than that. We get to all of that, that's one word. If you finish all of the bars and then go to the next one, that's a few words. You have to use one. Okay. Good luck, guys. The homework tonight is relatively easy. I recommend your homework. We are doing to the line. Good luck.